Hi, it's Mrs. Flynn, and we're here today to talk about the four phases of functions.
Woohoo!
All right, so what does that mean exactly? What are the four phases of functions? Well, whenever you're looking at a function, it can be described four different ways. One way it can be described is by using words.
Nice.
Another way we see functions written mostly is by equations.
Yes, we are very comfortable with all those equations we see.
And how else can we represent a function besides words and equation?
We could do a graph. We've seen lots of pictures with
a
our
graph. And sometimes how do you get to those graphs? Well, from a table.
Table values. Love the table.
All right. So what we're going to talk about today is linear functions, and we're going to be specific and talk about only the form of y equals mx plus b, which is called slope-intercept form.
All right, slope-intercept form. Oh, that's because do we know that m is the slope and b is the y-intercept?
Exactly.
Or am I jumping the gun?
No, I think so. I think that this is something they've learned many years past. So m represents your slope, and b represents your y-intercept.
Right. Slope or gradient.
Oh, gradient.
Being on this side of the Atlantic.
Yeah, that's right. Gradient. That's what we talked about last time. And just other side note, if it's a linear function, it is going to have a constant rate of change.
I love rates of change. What is the rate of change?
What does that mean? Constant rate of change.
So as things are changing. Well, I think that's probably our slope.
Slope.
Slope is our rate of change.
So it means that our linear functions are all going to have a constant slope or constant rate of change.
Nice.
Okay, let's go to the first example.
The cost of a taxi is €3 plus 0.4 per kilometer.
Well, if we're going to conduct the four phases of functions, one that's already done for us is the words.
It's already given to us. We got to take those and make it, do math stuff with it. The next one was equation.
Okay, so from the equation, that's actually not so bad. Let's first state our variables.
Oh, that's a good
What are the
point.
two things that are changing? One of them is going to be the total cost, so we can call that T for total cost of our taxi. And what does that depend on?
The kilometers, we go so the distance in kilometers.
So I'll say, okay, maybe D. You're right, that'd be better. D is the distance we go in kilometers. Okay, now can we write an equation from this? The cost of a taxi. Well, that's easy. That's total cost.
Oh, okay.
Cost of a taxi. T is in math means
Equal.
equal. €3. Oh, 3 plus, oh gosh, this is too easy. 40 cents per kilometer. 40 cents times our distance.
Distance. So if I go 1 kilometer, it costs me 0.4 plus the 3. If I go 2 kilometers, it's 0.4 times 2 plus the 3. Okay, I get it.
Well, since you're talking about that, we might as well go ahead and make our table.
Oh, right. I was just doing a table kind of out loud there.
Yeah. So we have distance versus total cost. So if we traveled 0,
Then
our total cost.
Right. Means I just step in the taxi driver will cost me $3.
What about, what do we want to do? Let's see what's more realistic.
With our distances, I think more realistic, if we could go 10 kilometers perhaps.
Okay, then that would cost, I can go over here on the side and write 3 plus 0.4 times 10. Do that calculation, that's just 4 plus 3, 7.
We could do 15 kilometers or 20 kilometers.
Okay, I was going to go for 20.
Okay.
Let's go for 20 and be done. 0.4 times 20. That's 8. Right?
Yep.
Plus 3. 10, 11. And now another way to check if it has a constant rate of change, we can look if our D is coming up by the same values, which is positive 10, and our T is coming up by the same values. That also shows a constant rate of change.
That looks just like our pattern unit that we were doing before.
Yeah, it's all connected. Everything's connected. Last thing, graph.
Oh, I like graphs.
This is just going to be a rough sketch. So we'll go here. Our independent variable is distance. So let's see, we did 0, 10, 20. And T is for the total cost?
Yep.
What do we want to go up by? 5?
Sure.
10? 15. So our intercept, our y-intercept, is at 0. 3.
3.
And then at 10, it cost 7. And at 20, it cost 11. Do we connect them?
Yeah, for sure.
Is it possible that we can have values in between our D?
Yeah, for sure. I could have 15 kilometers. I could go 15.111 kilometers. Every one works.
We'll maybe call this taxi cost. And we're done.
Nice. Okay, let's try another one. Example 2.
Y equals 0.5x plus 30. Well, let's see, our equation's already done for us. So next thing is words. Can we come up with a story? Let's see. Well, if we want to just keep up with the taxi, that would make it easy, right?
True.
We could do... We'll just do taxi again.
Okay.
Unless you want to be creative.
Be creative. Being creative, what could we do? Something half and 30. Oh, I know. Okay. I could say that I have a great big tub of water, and there are 30 liters of water in my tub right now.
Tub of water containing 30 liters. Aha.
Water is being poured into my container
at a rate of
0.5 liters per minute.
Water is being poured into my container at a rate .5 liters per minute.
Yep.
All right. There we go. There's our words.
Okay.
An equation. So let's just make our table here. This is X, which represents our minutes.
Minutes, yep.
And Y, which represents the total money. Money.
Liters.
Liters, thanks. Okay, so at 0, obviously this will be
30.
30.
If our time is 1 minute, then our liters is 30.5.
And if our time is
2 minutes, or do you want to go higher than that?
I was going to go at 10.
Okay.
Then we have 80, right? 35.
35.
35.
35.
Okay.
You might want to check for yourself to make sure you know how those numbers come.
Yeah, I was just doing those in my head. Okay. Graph.
Graph.
So here is our minutes.
Mm-hmm.
I'm just going to go 5 and 10. And we'll go up 5, 10, 15, 20, 25, 30.
Okay.
0 is 30. 5, 10, 15, 20, 25, 30.
Okay. There's 30.
And at 1.
It's 30.5.
At 10.
35.
These are just rough sketches.
Very rough sketches. It's hard to do it on the on the pad.
It is. And let's see. We'll call this our tub of H2O.
Super.
Okay.
All right. Great.
That's it for now.